Have you ever wondered how rock extracted from a mountain is transformed into the smooth walls you see every day in homes, schools, and offices? Behind every drywall panel is a gigantic industrial chain that moves thousands of tons of material, combining chemical processes, enormous ovens, conveyor belts, and high-precision machines working tirelessly. Let's discover how drywall is manufactured on production lines capable of creating millions of panels each year. More than 95% of homes in the United States use drywall for walls and ceilings, making it the most common material in residential construction. Each panel consists of a core of powdered gypsum, ground and pressed between two layers of heavy-duty industrial paper. This combination creates lightweight, fire-resistant panels that offer better sound insulation than many traditional materials. In the United States, a standard 4 by 8 foot panel costs between $10 and $20. While drywall may cost slightly more than simple wood or plastic panels, its quick installation and low maintenance make it a more cost-effective investment in the long run. The first step in manufacturing a plasterboard panel is extracting gypsum ore from vast mountain ranges, where it lies deep underground and is only accessible through large open-pit mines. Powerful drills create holes tens of meters deep, forming tunnels strong enough to contain explosives. Charges specially designed for mining are lowered into the boreholes, so that when detonated, entire layers of gypsum are ripped from the mountain. Thanks to these precisely timed explosions, the ore is ready to continue its journey and become an essential element of modern construction. Once the signal arrives from the lead supervisor, the blast is triggered, sending thousands of tons of gypsum tumbling down the hillside. Giant excavators approach the newly mined mounds, collecting fragments that weigh several tons per load. Each machine works at a steady pace, loading the ore onto smaller, specialized trucks. These vehicles travel along dusty roads to a temporary stockpile area where the material is transferred again, this time to high-capacity industrial dump trucks designed to move enormous volumes. From there, the gypsum begins its journey to the processing plant, where the stone will be transformed into an essential building material. Trucks loaded with gypsum rock arrive non-stop at the plant's receiving area. Each vehicle can carry several tens of tons, unloading directly into a huge storage yard next to the primary processing line. Engineers record the volumes and manage the distribution of the material, preparing it for the first stage, crushing. On average, this facility receives and processes more than 100 trucks a day, adding thousands of tons of raw gypsum to the production flow. Excavators enter the yard and lift large quantities of rock piled up in front of them. They work tirelessly, dumping the ore into the feed hopper of the production line. From there, the blocks are fed into enormous crushers that reduce the material to smaller, more manageable sizes for the next stage, drying. The crusher uses two massive rotating rollers that apply constant pressure to the rocks. Large pieces are trapped and broken into smaller fragments under the force distributed across the roller's surface. Thanks to the uniform motion, the crushing energy is used efficiently, resulting in more effective reduction. The result is a continuous flow of crushed gypsum exiting from the bottom. These rocks contain between 70% and 80% pure gypsum and are reduced to particles just a few millimeters in size. However, this process generates enormous quantities of dust which, if inhaled by workers over long periods, can cause serious illnesses such as lung cancer. Once crushed, the gypsum is transported on giant conveyor belts that run hundreds of meters inside the plant without stopping, ensuring a constant flow to the drying and processing area. After grinding, the fine gypsum is fed into a giant rotary kiln for heating. Here, the dihydrated calcium sulfate slowly loses water and transforms into hemihydrate calcium sulfate, known as calcined gypsum. Flames from burners are projected directly into the kiln, reaching temperatures from 300 to over 660 degrees Celsius, with hot spots approaching 760 degrees Celsius. The heating process lasts for hours to gradually release the water and prevent the crystalline structure from degrading. Engineers monitor and adjust the zoned temperature control, ensuring uniform, high-quality calcination. Once heating is complete, the powder is sent to the mixing area to prepare the paste or slurry. Before mixing, technicians take a sample to the laboratory, where it is combined with water and additives such as starch or setting modifiers. The mixture is stirred, and parameters such as expansion, strength, and setting times are evaluated. The results must meet precise standards to ensure batch stability. With the approved formula, the automated system mixes gypsum, water and additives in exact proportions, quickly forming a thick paste ready for molding. Drywall isn't made of just gypsum. The core is sandwiched between two layers of industrial paper that provide strength and prevent warping. Enormous rolls of paper, hundreds of meters long, are fed into the production line. Specialized machines unfold and tension the paper to maintain a smooth surface. Operators adjust speed and tension to keep the paper perfectly aligned. Gypsum paste is forcefully sprayed onto the bottom layer of paper through high-speed nozzles that distribute the mixture evenly. This allows the core to bond firmly to the paper. The freshly applied layer passes through giant rollers that establish its exact thickness. These rollers rotate at a constant speed and apply calculated pressure to level the mixture. The final thickness typically varies between 9 and 15 millimeters, depending on the type of panel. After leveling, an automated system sprays a fine water solution, sometimes with additives, onto the surface to eliminate microbubbles that could weaken the panel. The ultrafine droplets do not deform the panel. Specialized machines then precisely profile the edges, creating clean lines that facilitate on-site installation. The formed panel enters the automated cutting area. Sensors measure the exact length and synchronize the industrial blades, which cut it into standard sizes such as 2.4 meters or 3 meters. The cutting speed is carefully adjusted to prevent cracking or surface displacement. The paper folding process then begins, wrapping the edges of the gypsum core. Mechanical systems precisely fold the sheet, creating a firm covering that protects the panel and prevents the gypsum from cracking. This layer also provides a uniform surface ready for painting or tiling. The panels move into a large drying chamber, a completely enclosed space designed to remove any remaining moisture from the gypsum core. Inside, the environment is controlled with extreme precision. Temperatures can range from around 300 degrees to over 660 degrees, depending on the stage of the cycle. Each drying session lasts approximately 30 minutes, enough time for the heat to penetrate evenly and expel the moisture from the inside to the surface without deforming or compromising the panel's structure. Inside this chamber, powerful fans distribute the hot air in all directions, ensuring that each plate receives the same heat intensity. This constant airflow prevents some areas from becoming more humid than others and ensures that all plates emerge with the required level of rigidity and strength to continue the process. Once drying is complete, the hardened panels are automatically moved to the edge sealing line. In this section, high-precision machines apply specially designed paper strips to protect the sides of each panel. These strips are typically printed with the manufacturer's logos, technical specifications, batch numbers and quality standards, allowing for clear product identification upon arrival at the market. The paper adheres firmly to the edge, creating a protective layer that reinforces the structure and prevents the edges from chipping during transport, loading or storage. Thanks to this step, the panels retain their shape and integrity until they arrive at the construction site, ready to be installed without damage or imperfections. Finally, forklifts stack the panels in the storage area, arranging them in tall blocks ready for large orders. When an order is placed, forklifts load the panels onto specialized trucks that distribute them to construction sites and building centers. Once out of the factory, drywall is very easy to install. It's lightweight, strong, and quick to work with. In the United States, more than 90% of homes use drywall for interior walls. Its low cost also makes it a popular choice. In Europe, drywall recycling is common practice. A single panel can last between 30 and 50 years in a building, and when the building is demolished, the drywall isn't discarded as ordinary waste. It's collected for recycling. Recycling plants handle tens of thousands of tons per month. Recycled drywall costs 2 to 3 times less than mined drywall and can be recycled up to 10 times while maintaining nearly the same quality. The recovered drywall is fed into industrial shredders that reduce it to a fine powder. It is then processed and prepared to become raw material again. Unlike the United States, Europe has implemented more advanced technological systems that allow recycled paper to be incorporated directly into new gypsum boards. This method not only reinforces the panel's structure, but also significantly reduces the amount of ore that must be extracted from quarries. The paper used comes from industrial and domestic waste that undergoes a meticulous sorting process to remove impurities and ensure that each fiber is suitable for reintegration into the production chain. Once the recycled gypsum and processed paper are ready, both materials enter a modern, fully automated mixing system. There they are combined with water and a series of additives that improve the cohesion, setting time and mechanical strength of the final product. After constant and controlled mixing, a homogeneous, uniform slurry is obtained with the ideal consistency for molding into new panels. The material flows into a section where it is spread over a continuous base, forming a wide layer that is still soft and flexible in its first few seconds. To achieve a uniform surface, the sheet passes through precision rollers and flattening systems that eliminate air bubbles, correct irregularities, and ensure a consistent thickness throughout. Subsequently, automatic blades calibrate the final thickness and cut the sheet into standard sizes that facilitate its transport, storage, and installation. Once cut, the panels move on to the packaging stage. Here, they are carefully stacked in large blocks and pass through machines that wrap the edges with protective materials, preventing damage during transport. Thanks to this process, the panels arrive at distributors and construction sites completely flat, intact, and ready for use. Thus concludes the complete journey of drywall. From America to Europe, this gypsum board is not only a staple in most modern interiors, but it has also evolved into a more sustainable material, capable of being recycled multiple times without losing quality. Behind what appears to be a simple surface lies a story of engineering, innovation, and commitment to the environment, an everyday product that reflects how technology can transform construction toward a more efficient and responsible future.